Hi Blendy friends, welcome to Devlog number 7. Today I'll be showing a particularly dark miracle, how to animate hundreds of trees in the Blender game engine. But thank you to my patrons. Without you, this wouldn't be happening and the Blender game engine would not be getting its day in the sun. So without much further ado, let me show you the actual trick. Here's 100 trees. I think this is this is 514 trees. So you can see they're all animating in the Blender game engine. And normally something like this would really be taxing and it wouldn't work very well, especially for mesh deformation. That's not just in Blender game engine, but most game engines, this many mesh deforms would actually be pretty expensive and take a lot of processing. So what trick am I using to animate this? If you've guessed shader nodes, you are correct, but it's a little bit trickier than just your standard warping. So these are all instances of a single mesh, which can be seen over here. And you can see this is a tree, and you see there's actually a warping going on. It's actually, the branches are waving back and forth. So it's not a simple textured deform as much as it is a warp where it waves like this. And that's being used, that's a simple trick using vector math rather than animation. And what does that mean? So if you see this blue trunk here, I'm just using this to illustrate the animation. So it's a simple extrapolated vector or animation curve that's just going off in one direction forever, which isn't the same as what you would think it would be for an animation. You'd think it would be going up and down like this and maybe cycling like this. But in this instance, it's a little bit different, and it's using vector math to achieve the result. So if you look at the nodes, these are shader nodes, and this is the material. It's a triangle, basically. And let's isolate it so we can see what it's doing. Here is a single branch. It's just a two-dimensional projection of a branch, and the secret sauce, here it is, it's the blue value of a single material that's being converted to black and white, and then it's being added back in with global coordinates so that there's randomization based on where the tree is in the world. And it's taking this little tricky thing here. So Blender Game Engine does not allow you to rotate vector coordinates. So you can see it's taking the UV vector and is rotating it and then applying it to this texture. And this texture, which is also here, is a simple X shape with 4 different branches. And what it's doing, if we jump inside, is it's taking the vector information, it's separating out the X and the Y, and then it's plugging those in with the original blue vector path. And if we look in here, it looks complicated, but hold on, it's not that bad. It's simply taking the cosine and the sine of that angle, so that vector, that blue vector, and then it's saying, okay, for the UV vectors X and Y, multiply. And for the UV vectors X and Y, multiply for both the cosine and the sine. And then it's going to take those products, it's going to subtract them, add them, and then those are the two values that are now the X and the Y. So it's getting the cosine and the sine with the vector displacement, and that's providing a rotation. So that seems weird, that all that stuff, that's kind of a mouthful. If you look at what I'm doing from a bird's eye view, this is essentially the texture animating. You see, it's waving back and forth. And what makes this really effective is it's not just the same for games or a Blender game engine. This could be used for anything. This could be used for films. It could be used for large scenes that you need a lot of animation, but you don't want to process all this physical simulation. So you can see I can slow down, I can speed up the wind, I can change all sorts of values just based on this one single curve, which is really cool. So here we have a nice simple floaty texture, and if you actually kind of get a good look at it, you can see it's actually kind of warping and waving. It's really cool. And this is computationally efficient because I can basically consolidate a waving branch to a single triangle, or maybe 2 triangles if I want to get axial movement, X and Y. So when it's animated, it looks like a fairly convincing animation that happens in a game. Clearly you can see that I haven't clipped or UV mapped this branch properly, and that's simply I have to go in here and fix it like this. And there we go. And now you get some pretty cool movement, and you have a nice little animated texture, and you can use this everywhere. And I don't need to trigger multiple animations. So Blender Game Engine can do this, Unreal can do this, Unity can do this. Blender Game Engine requires you to make your own vector nodes here and do the math yourself, but it's computationally more effective because it doesn't have a z-value. I'm not doing any calculations for this because it's irrelevant, so I can just use the x and the y. If you look at it purely from a vector standpoint, you'll see it's just the RGB information skittering. So if I turn all this off and I just look at it, just simply the vector nodes, if you look at a normal UV vector, it's this. But if I take the UV vector with the rotation and I look at it, you can see it's this, and it's rocking back and forth. So it's got this neat little rock, and obviously the color's a little different because I messed with the Z value. If I made that 1 or 0, it would look identical to the UV mapping, because UV, of course, doesn't need a Z value. It just needs a X and a Y, because it's two-dimensional. So if I turn this on, it's just rotating, and if I turn this on, it's flat. And that's it. So all patrons get access to this file, and you can see how it works, and you can take this file and use it, retrofit it for anything in Eevee, Cycles, or any other game engine. It's a very effective way to get a lot of good, convincing motion out of something without having to write a complicated shader or a complicated script. But you can use this as an animation technique, and it really helps you save a lot of processing while still being able to achieve some really cool, convincing movement. Thank you again to all my patrons, all my Blendy friends. Without you, none of this would work. And to thank you, I have decided to start bathing everyone's name in blood. So all patrons get access to this file as well as all other files. And also they get to their names in a vanity card titled Painted in Blood. So today I'm painting Rhyperian's name in blood using the Flip Fluids add-on. And this is simply a script that I did that randomizes motion and splatter. Here it is. And this goes to Rhyperian for his continued support in the project. I'm going to get to all patrons, and I'm going to do all of you one at a time, and everyone gets their own randomized bloody title card. Thank you guys so much for all watching. All my Blendy friends, I really appreciate the support, and I'll see you guys in the next devlog.